We are going to review graphing quadratic equations because the next new topic that we're going to see is graphing quadratic inequalities. So we have to remember how to graph quadratics. So first of all, if we have a quadratic that's in standard form, we always start by finding the x-coordinate of the vertex using this formula, opposite of b over 2a. Once we have that, we can plug it into x to find the y-coordinate of the vertex. Then you're either going to make a t-chart, or ideally, you can use C as the y-intercept and then reflect it over. So here's an example. We're not going to identify domain and range. We're just going to graph that's in standard form. So we start with the x-coordinate of the vertex using that formula, opposite of b over 2a. So the opposite of b is 4 over 2 times a, which is negative 2. So this is 4 over negative 4, or negative 1. I then plug that into the original to find the y-coordinate of the vertex. So I've got negative 2 times negative 1 squared minus 4 times negative 1 minus 3. So here, negative 1 squared is 1 times negative 2 is negative 2. Negative 4 times negative 1 is positive 4 minus 3. So the y-coordinate of my vertex is going to be, this is 2 minus 3, so negative 1. So my vertex is an x value of negative 1, a y value of negative 1. I can go and plot that point. Then I can use my y-intercept of negative 3. And then remember, everything is symmetrical through that vertex. So I just reflect it over to the other side, and I connect to get my parabola. Here's another example in standard form. So again, opposite of b over 2a. So here that's going to be positive 4 over 2 times negative 1. So it's 4 over negative 2, or negative 2. Find the y-coordinate of my vertex by plugging that in for x. So opposite of negative 2 squared minus 4 times negative 2 minus 7. So negative 2 squared is 4. Apply the negative, and that'll be a negative 4. This is going to be a plus 8 minus 7. So here, negative 4 plus 8, that's going to give me 4. And then 4 minus 7 will give me negative 3. So my vertex here is negative 2, negative 3. So negative 2, negative 3. Again, I can use my y-intercept at negative 7, symmetrical through my vertex, and reflect over to the other side. If you didn't use that y-intercept, remember you can always make a t-chart. You would put your vertex in the center and then count up and down from this x value. So maybe I put in a negative 1 and a negative 3. I then plug this into my original. So if I plug in negative 1, got the opposite of negative 1 squared minus 4 times negative 1 minus 7. So this is going to be the opposite of 1, so negative 1 plus 4 minus 7. So it's going to be a 3 minus 7, or negative 4. And then it's symmetrical, so it would be a negative 4 here as well. So it would be this point, which I would then reflect over to the other side. So just another way if you forgot about the y-intercept trick. We also have graphing in factored or intercept form. Remember that if we solve for x here, that's your x-intercepts. So if I take x minus 2 and set it equal to 0, I add 2 and I get x equals 2. Similarly, I can take x plus 2 equals 0, subtract 2, and I get x equals negative 2. This means that my graph is going to cross the x-axis at 2 and at negative 2. Then the x-coordinate of the vertex is halfway between those x-intercepts, because my graph is symmetrical. So here, the x-coordinate of my vertex is 0. I just need to figure out how far up or down I need to put that point. So I plug 0 in for x. So I've got 3 times 0 minus 2 and 0 plus 2. So this is 3 times negative 2 times 2. So here, 3 times negative 2 is negative 6. Negative 6 times 2 is negative 12. So it's going to be slightly off my graph here. Just going to extend it down here to negative 12. My pen won't work with the screencastify on there. Okay, so we're just going to squeeze another tick mark in there. Okay, so then we can connect and get our graph. Here's another one that's in factored form. So again, find those x-intercepts. X minus 5 equals 0. I can add 5 to get x equals 5. X plus 4 equals 0. I can subtract 4 to get x equals negative 4. So my graph's going to cross at negative 4 and positive 5. Now here, it's a little trickier to visually see where the halfway point's going to be. So remember, I can always add those two together and divide by 2 to find that halfway point. So it's going to be 1/2. So when I go to plug 1/2 in, I've got 1/2, and then in parentheses here, 1/2 minus 5, 1/2 plus 4. And I can go ahead and I can type all of this in my calculator because I'm really going to want a decimal value anyway. So if I type in 1/2 and then 1/2 minus 5 and then 1/2 plus 4, that's going to give me negative 10.125. So just slightly under negative 10. So here I'm going to go to 1/2 for the x coordinate and then just slightly under negative 10. And I can connect to make my graph. The last form of graphing we had was vertex form. So remember, if you have a times x minus h quantity squared plus k, your vertex is located at the point hk. H is always the opposite of what the sign is here. So in this case, my vertex is located at negative 3, negative 1. So I'm going to go negative 3, negative 1. And then here, I really do have to make a t-chart. There's no trick to kind of help me out with another point. So pick something bigger than negative 3 and smaller than negative 3. So maybe negative 2 and negative 4. And I just plug those in to solve for y. So if I do that, I've got 2 times, say I plug in the negative 4 plus 3 squared minus 1. And then watch your order of operations. Parentheses first, so it's going to be a negative 1 squared. So that's a positive 1 times 2. So 2 minus 1, which will be 1. And then again, that gets reflected over. So I've got a point here and a point here. Here's another example. Again, start with your vertex. So here it's going to be a positive 1, positive 4. And then we can make that t-chart. So pick something smaller than and bigger than 1. And then pick one of them to plug in. So say I plug in the 0. 2 times 0 plus 1 squared plus 4. So it's 2 times 1 squared, which is going to be 2 plus 4, so 6. And then I can reflect that over to the other side. So what we'll be doing next is that we'll have these quadratics that are actually inequalities. So we're going to graph in the same way, but then you're going to have to shade the solution region. So that'll be in the next section.